Hi, Assalamualaikum. My name is Amanina Farhana binti Ahmad from Faculty of Mechanical and Automotive Engineering Technology, University Malaysia Pahang. So for today, I will present my research title, Influence of Polymer Coated Aggregate on Aggregate Impact and Crushing Value.
Introduction. HMA, hot modified aggregate, can be formed by mixing the selected aggregate with asphalt binder. 95% of HMA made up of aggregate. Characteristic of aggregate can be affect the performance of HMA pavement. Characteristic of aggregate can be reinforced by presence of polymer coating. For problem statement, there are three main failures that occur in wearing cross layer, which is fatigue cracking, thermal cracking, and rutting. And all these three failures are mainly because of excessive load and high temperature. Rutting is considered as one of the most common and destructive pavement distress, and rutting occurs due to the weak mixture and weak substrate. So, by coating the aggregate, it can increase the strength of the weak mixture. So for objective for this study is to evaluate the properties of aggregate by comparing the coating aggregate with unmodified aggregate.
For material, I have three main material that I use in this research. First is aggregate. Actually, for HMA, there are three type of aggregate, which coarse aggregate, fine aggregate, and fine aggregate. For PET, second is PET. PET is a semi-crystalline thermoplastic polyester, which can be softened around 120 to 160 degrees Celsius. And there is no harmful gas evaluation during that range of temperature. For this research, PET plastic bottle were collected and shredded to size of 0.425 to 0.075 millimeter. And for latex, I use high ammonium natural rubber latex, which it contains 64% water and 36% rubber and a small amount of impurities. Latex only can last for 3 hours in liquid form. Therefore, ammonia is used to preserve the latex and to keep latex in liquid condition. For methodology, AIV test. AIV test is to measure of resistance to sudden impact or shock, which is this test. I use a guideline in Malaysia that the limit average aggregate percent loss for AIV test must less than 30%. For ACV test is set to provide a relative measure of resistance of an aggregate to crushing under a gradually applied compressive load, which this test also I use a guideline in Malaysia that the limit average aggregate percent loss for ACV test must less than 30%. This is the flow for my experimental work. First, I do the AIV test for 1%, 3%, 5%, 7%, 9%, 11%, 13%, and 50% of PT. And then I do the ACV test for 1, 3, 5, 7, 9, and 11% of PET. And after that, based on the AIV on the previous experiment, which is a coated PET, I do the combination of PET and latex for AIV test. And then all these tests was according to the standard specification of road work in Malaysia. For result and discussion, this is the graph for AIV test. From this graph, we can see that whenever the amount of PET is increased, the aggregate percent loss was decreased. The aggregate loss start to increase when 50% of PET is used to coat the aggregate. Without any plastic coating, the aggregate are still in good condition for road surfacing to comply the SSRW, which the aggregate loss is 17.04%. So, 13% of PET coated aggregate will achieve the lowest aggregate loss, which is 8%. From the indicator, the combination of latex and PET was used to coat the aggregate for the next test. For ACV test, this is the graph for ACV test. From this graph, you can see that whenever the amount of PET is increased, the aggregate percent loss was decreased. The aggregate loss start to increase when 11% of PET is used to coat the aggregate. And without any plastic coating, actually, the aggregate is still in good condition to be used, which the aggregate loss is only 25.4% aggregate loss. and 9% of PET aggregate was achieved the lowest aggregate loss, which is 16.33%. For AIV test, combination between PET and latex, this is the graph for the test and this is the figure for the test, which is latex and PET is combined to coat the aggregate. From the graph, you can see that the total amount combination of latex and PET is 30%. Combination of 7% PET and 6% latex seem most suitable, which is achieve 3.48% of aggregate loss. Combination of PET and latex can increase the strength of aggregate because the presence of latex can make the aggregate elastic and able to protect aggregate from strong impact. In order to produce high quality pavement, this test also help to determine the durability of stone that have the ability to break into smaller pieces if repeated impact is applied.
For comparison, I do the comparison between my research and the other researcher. From this table, we can say that PET coated aggregate can help to fill the pores at the surface. Void sand air cavity in the aggregate can be reduced by coating the aggregate with polymer. The impact value test of Kumar and his friend's study show that lower percent of aggregate loss compared to my study. This might be due to they use different type of plastic, which is polypropylene. Polypropylene has melting point of 164 degrees Celsius while PET is 252 degrees Celsius. Gurpreet Singh and his friend was studied about coating the aggregate by using PET. From the comparison, it showed that same trend, which when the polymer coating increased, the aggregate percent loss decreased. For conclusion, I have 5 things to be concluded. First is the lowest percent of aggregate loss for crushing value test is 16.34% when PET coated is 9%, while impact test is 8% aggregate loss when PET use is 30%. Number 2 is the percent of latex has caused the strength of aggregate to increase, where the percentage loss value when perform impact test is very low that it can achieve 3.48%. Number 3, the quality of aggregate can be improved when the surface of aggregate is coated with polymer. Number 4, the quality of pavement can be improved as the aggregate strength increase. Using waste plastic in road construction are able to help the waste plastic disposal process in an eco-friendly method and also able to create job as rag picker. So that's all from me. Thank you.